what's in the essay? 22 anti-Copernican arguments. All right. Of these, 4 are what Ingoli called theological arguments. The other 18 he called physical or mathematical arguments. Ingoli's first argument is a mathematical argument regarding triangulating the distances to the sun and moon by observing them from different locations on Earth. Ingoli says the results of the triangulation are inconsistent with heliocentrism. Arguments 2 and 3 are mathematical arguments pertaining to how, were the Earth orbiting the sun, there would be observable effects visible in the stars, and there are not. Number 4 is another mathematical argument that Copernicus was wrong regarding certain technical details of Mercury's and Venus's orbits. Arguments 5 and 6 are physical arguments. Number 5 says that heavier materials move down, lighter materials move up. Number 6 says that in a circularly agitated sieve, shaken around like this, okay, heavier bits of material collect at the center. These two things suggest that the Earth, which is heavy, should be at the lowest point, that is the center, in a universe of circling lighter celestial bodies. Next comes 2 theological arguments. Number 7 concerns the words of Scripture, the sun and moon being equally described in Genesis as lights in the firmament. Number 8 is on the location of hell. Then comes a slew of mathematical arguments. A falling ball should deflect from the vertical, and launched projectiles should behave differently at different latitudes on a rotating Earth. These things do not occur. So Earth does not rotate. Number 11 and number 12 are more arguments about the Earth's motion being observable. Whoops, and I should probably move forward there. Number 11 and number 12 are more arguments about the Earth's motion requiring observable effects not observed on the stars. Number 13 is that Earth's motion should have an observable effect on daylight. Number 14 is that the observed motion of comets are inconsistent with a moving Earth. Number 15 through number 17, right, deal with how Earth maintains its orientation relative to stars, so that we have a North Star, even though the Earth orbits the sun. Copernicus attributed this to a third motion of the Earth. So in Copernicus's system, the Earth has one motion. First motion is revolution about its own axis. Second motion is revolution about the orbit about the sun. Third motion is a motion counter to the second motion, so as to retain the orientation relative to the stars. Ingoli's arguments were that all of this motion was unneeded, since Earth need not move at all. That's number 15. As well as complicated and physically improbable. That's 16 and 17. Right. Next comes 3 more physical arguments. 2 relate to the idea of heaviness. Earth is heavy. Okay, this is part of number 18, and hard to make move. Celestial bodies at the time were theorized to consist of a special lightweight element that moved naturally. Okay, astronomers do this, right? Something's happening in space. You can't go there. Okay, something's going on. You invent a material to explain you say, oh, there's some material not found on Earth that's out there in the universe, and this makes all this stuff work. Dark matter, dark energy. That's the modern version of it. Okay, back then it was called fifth element. But then it was a different idea. But it's still same basic problem solving method. Okay, so the idea was that the celestial bodies would be made out of this special material. They'd be lightweight. They'd be easy to move. So the next thing is that heavy stuff moves naturally toward the center of the Earth, and so the Earth, being composed of heavy stuff, cannot move naturally around the sun. The third, number 20, was that Copernicus lacked consistency in what he put into motion. All right, both a dark body like Earth and bright bodies like the planets are moving. And then the final 2 arguments are theological. Number 21 concerns the words of Scripture again, Joshua commanding the sun to stand still. Number 22 cites the words of a Vespers hymn, not to be taken lightly. Ingoli warns. Cardinal Bellarmine likes these kinds of arguments. Right. So, now, Tycho Brahe. Turns out Ingoli gets many of these arguments from Tycho Brahe, the Danish astronomer. Ingoli cites Brahe's works complete with page numbers. He'll give Tycho, book, page. Okay. Brahe had died 15 years earlier, but he had been the most prominent astronomer of the age. He had been lord of his own island, where he ran a huge astronomical research program with all the best instruments and all the best observers, all funded by the King of Denmark. Brahe had been an anti-Copernican. Recall Castelli's breakfast with the de Medicis. Cosimo Buscaglia had asserted that all Galileo's astronomical discoveries were real. Okay? But he also asserted that Earth did not move. Buscaglia could have this cake and eat it too, because Brahe, impressed with aspects of the Copernican system but rejecting the idea of Earth's motion, had developed his own system. Like this. Okay? In Brahe's system, the Earth is at the center, the moon goes around the Earth, the sun goes around the Earth, the stars go around the Earth, the planets go around the sun. Okay? Now, Brahe had calculated that that were the stars as distant as Copernicus had supposed, so that Earth's orbit would be nothing by comparison, producing none of the previously mentioned observable effects in the stars, then those stars would have to be enormous in order to appear as large as they do in the sky. Brahe measured their apparent sizes. Brahe could measure anything. He was an extremely good astronomer. Every last star, Brahe calculated, even the smallest, would dwarf the sun, and that, Brahe said, was absurd. Okay? This is what Brahe did. Okay? When you look up at the stars, they as in this picture, okay, they have differing sizes. The more prominent ones look bigger, the less prominent ones look smaller. Okay? The name for the bigness of stars is called magnitude. Those of you who are in the introductory astronomy classes and you've learned about magnitude, you learned that they have this weirder thing where the bigger numbers, where the littler numbers mean the brighter stars. You know, why is that? Here's why. Okay? Because they're like seeds in a tournament. Okay? The biggest and brightest stars, the first class stars, are 1. Second class stars, 2. Third class stars, 3. Fourth class stars, 4. Fifth class, 5. Sixth class, 6. That's it's like first seed, second seed, third seed, fourth seed. You know, something like that. Okay? That's why the numbering system works the way it does. Because it was, so the biggest stars were first magnitude. That's what magnitude means. Magnitude means bigness. So how did Tycho figure this out? Okay, like this. He says, okay, I look at a star. I measure its diameter. Okay? And then I look at like the moon. Okay? I look at it. And basically Brahe works out that a first magnitude star is about 1/15 the diameter of the moon, as you see it in the sky. Moon and the sun appear about the same size in the sky. So a star looks about 1/15 the diameter of the sun in the sky. Okay? That means that for the star to be the same size as the sun, it has to be about 15 times further away than the sun is. Okay? Now, alright? In the heliocentric system, okay, the annual motion of the Earth around the sun should be reflected in the stars. That's called annual parallax. That's one of those effects that Ingoli is talking about that I just breezed through in his list of arguments. He gives in more detail than I do. There should be annual parallax. There's none that anyone can see. Okay? And so, the Copernicans argue, well, why can't we see that? Because the size of the Earth's orbit is so tiny compared to the distance to the stars that the Earth's orbit is negligible by comparison. As Copernicus said, this proves their immense height. Every visible object has some measure of distance beyond which it is no longer seen, as is demonstrated in optics. Okay? Well, here's the problem with that Brahe worked out. Look, if you have an object that has a certain size, like that star, okay, but then you go and say, no, that is not this far away. It's hundreds and hundreds of times further. Then, when you make something of a given size further away, you require it to be bigger. Okay? So that the further away, and you say further and further away means bigger and bigger and bigger. Okay? So Brahe works out, look, in the Copernican system, those stars have to be really, really far away. He calculates they have to be 700 times further away than Saturn to have no measurable parallax. Okay, the Saturn is about 10 times further away than the Sun, so that's 7,000 times farther away than the Sun to have no measurable parallax. Okay, remember, based on his measurements, if the stars were to be the size of the Sun, they'd have to be 15 times as far away. They're 7,000 times as far away, which means if they were 15 times as far away to be the size of the Sun, 150 times as far away to be 10 times the diameter of the Sun, 1,500 times further away to be 100 times the diameter of the Sun, 7,000 times further away is going to be several hundred times the diameter of the Sun, is how big a star has to be. Okay? All right. So, Brahe said this is crazy. Okay. By contrast, in Brahe's system, the stars are right past the planets. Saturn is 10 times further away than the Sun is. The stars are a little bit past that. 15 times further away, remember, makes the star the same size as the Sun. So, they're not quite 15 times as far away. They're a little bit smaller than the Sun. Okay? No problem. Okay, so, stars are not so different. Distance. In his system, the Sun, Moon, and stars circle an immobile Earth, while the planets circled the Sun. The stars lay just beyond the planets and did not have to be so huge. In Brahe's system, celestial bodies all fell into a consistent size range. So, this is Brahe's calculation of, that's the Sun, right there, that. This is the size of an average-sized star in the Copernican system, according to Brahe. Okay, this is the Copernican system right here. So, Brahe says, look, every star has to be just huge like this. Okay, whereas by contrast, in my system, says Brahe, everything works out nicely. Okay, here's the Sun, there's Mercury, there's Venus, there's Earth and the Moon, Mars, Jupiter, and Saturn. Those are the actual sizes that he calculated out, the actual relative sizes, and then this is a first magnitude star and a second magnitude, first magnitude and third magnitude. Okay? All the celestial bodies fall within a harmonious, reasonable, consistent size range between the Moon being the smallest and the Sun being the biggest. Right? By contrast, he said in the Copernican system, this is stupid. All right. He said, that's that whole diagram that I showed there against one third magnitude star. A first magnitude star I didn't put on here because it's so big, it just looks almost like a straight line. Okay, you could hardly even see the curve. Even a tiny sixth magnitude star completely dwarfs not only the Sun, but a good chunk of the whole solar system. Okay. Brahe thought this was nuts. Of course, Ingoli brings this up. All right, the star size issue is a solid argument for Tycho's system, and Ingoli brings up the star size question right after his arguments number 2 and 3, and of course he cites Brahe by page number. All right. Galileo's discoveries are all fully compatible with Brahe's system. Anti-Copernicans like Buscaglia could accept Galileo's discoveries, like those phases of Venus that proved it to circle the Sun, because in Brahe's system, Venus circles the Sun, which in turn circles an immobile Earth. Okay, so you say, telescope shows that Venus circles the Sun. In the Copernican system, Brahe says, yeah, Venus circles the Sun in my system too.